going to solve the LeetCode problem task scheduler. So this problem is categorized as a common Facebook coding interview question. So in this problem, you'll be given an array and an integer as inputs. So this array represents a set of tasks that a CPU needs to do, and the integer represents, I think, the amount of cooldown period that should occur between two same tasks. So as an example, here you are given a bunch of tasks, and since the value is set as 2, in order to repeat the same task, you have to have a cooldown period of 2 between them. So here they have shown how it's possible. So we have A, then followed by task B. So now you couldn't repeat the task A and B again. So there's one moment of idle timeout, and then again they do A, B. So that way, this we need to find the quickest way to solve all of the tasks and also respect the cooldown period. So here's the one with n is equal to 0. It's just returning since there's no cooldown period at all. And here they're given an example where cooldown period is 2 and they're given this input. So they keep trying A, B, C, then they repeat A, D, E, and A, F, G. So the easiest way to solve it, I think, looking at this, you have an idea, is using the greedy algorithm, where we always try retrieving the most frequently occurring task and try solving it, because that's the one which we'll need to repeat the most amount of times. And so anything which has us retrieving either the most frequent one, we always use a priority queue data structure. So that's how we can try solving it. We can take all the tasks and the count of how many times they occur, put it inside a priority queue, keep retrieving the most common task, and keep and then the second most common task, and we keep doing it until the cooldown period ends, and we'll repeat it until all the tasks inside the array have been processed. So yeah, let's try solving it. So first thing we need to do is create a hash map. So this map will be used to keep a track of what the count is for each of the tasks. So I'll just add that. So now we're just going to go over the list of tasks inside the array and keep adding it to the hash map. So yeah, the first thing we did was just add them. So now we have a count. So now we have hash map where the key is the character and the value is the number of time it occurs inside the array. So we are going to add it to a priority queue. So let's try that. So let's initialize the way we are going to sort it. So we're using a lambda for this. So the way we'll do it is that whatever values in the hash map, that's the count, and we need to be it to be sorted in the descending order. So we'll try this hm.get b minus hm.get a. So this just stores it in a descending order. So now we'll keep a count of how many times we need to execute the task and how many times we have to be idle. So let's create two integers for that. And task count. So after that, let's add all of the values from the task array into the priority queue. Oh, sorry, from the hash map into the priority queue. So for that, we'll create another for loop. So now that everything has been added, we are now going to traverse down the priority queue and keep executing the task and keep a count on how many times we have executed a task and how many times it has been idle. So let's create a while loop for that. So I'm creating another queue data structure. So this is just to keep, so every time we remove a value from a priority queue, we'll just add it back in the end. So let's create one more data structure for that. Spelling error here. So the value n represents the minimum amount of time there should be between the two, between two tasks. So for that, what we're going to do is we're going to create a for loop, and we're going to do different cycles. So in each cycle, there should be a minimum of n steps. So let's create a for loop. Sorry. So let's create a for loop for that. So int So setting the value less than equal to n, because since 2 represents, if the cooldown period is 2, then one cycle will have to execute 3 tasks. So that's why I'll just say less than equal to. Okay, I think I made it. Alright. So we have two things to consider. One is if there are values inside the priority queue. If it is, we just add, we can execute a task itself. So for that, we'll just increment the value of the count. So so here we have just incremented the task count, because every time there's a task to be executed inside the priority queue, we remove it, execute the task. Else, if there's no task, then we need to have a cooldown period. So we'll just add a condition where we check if all the tasks have been completed. If they have not been completed, we know the CPU has to be idle. So for that, we'll add another count for it. So if we say while task So yeah, so we have run a cycle and we add the task and the idle count. So after that, all the values that have been removed from the priority queue have been added to this queue data structure. So we just need to add it back. So we'll just create another while loop for it. Since we already executed the task, when we add it back to the hash map, we just decrement the count of it. Next step is to see whether we need to add this task back to the priority queue. So if the count is greater than 0, then we haven't executed all the tasks yet. So we'll just add a check for it. So if So we're just adding it back. So yeah, this way, if all the occurrences of the task have been completed, we won't add it back to the queue. So yeah, like based on this condition, we'll keep doing it until all of the tasks have been processed. And at the end of it, we'll just return the count of the number of times the task was executed and the number of times it was idle. So yeah, just doing a recap of the solution. First thing we did was we created a hash map, and this was just to keep a track of the number of occurrences of each task. After that, we are creating a priority queue, and we try having it sorted in descending order. So the most frequent one will be always stored at the top of the queue. So yeah, after that, what we do is we keep removing the most frequently occurring task. We increment the task count, and if there's no task available and the cooldown period is not complete yet, we have to keep increasing the idle count. And we keep doing it until all of the tasks have been processed and we just return the count. So yeah, let's try running it. Okay, all the 3 use cases have passed. I'll try submitting the solution. So yeah, the time complexity of this is O of n, where n is the number of tasks. And the space complexity also is O of n. So we are using a priority queue and a hash map, but all of them are still linear, so it'll be like O of 3n maybe, but it's still a linear solution.